morning. We are going to have our second invited lecture. This one will be given by Mr. Gonzalo Piernavieja. The title is Island as References of Circular Economy Models, Potential and Challenges. Let me tell you a little bit about Gonzalo. So, Gonzalo has a degree in physics from the University of Munich and a postgraduate program in energy and environment management from the Technical University of Berlin. He has been in Germany for, 25 years ago. 25, it seems too much because you are such a young guy, but anyway, 25 years ago. And he contributed to set up and optimize one of the first grid-connected photovoltaic installations in Germany at local utility of Munich. Back now to Canary Islands, he worked 3 years at the University of Las Palmas de Gran Canaria in energy and water research development programs. After that, he joined the Canary Island Institute of Technology, created 20 years ago, and where he has helped to configure the research and development division. Now he is the director of the Research, Development and Innovation Department of the Institute, which has about 150 people and 9 departments. So, welcome, Mr. Gonzalo, and please, the stage is yours.
Thank you, Mario. Good morning to everyone. First of all, I would like to thank the organizers, IST, and particularly Neven Dwich, with whom we have been collaborating in the last years, particularly island issues. It's an honor for me to be here. We islanders, for us islanders, it's always difficult to come to the places, but we are here. And something about my institute, introductory remarks. We are not an academic institution, but we are a company, so we have to make money, or at least we are not allowed to make losses. So it's a company that actually works as a tech center. It belongs to the regional government of the Canary Islands. I will talk a lot about the Canary Islands. And as you see there, the departments or the activities we are carrying out, it's 20 years old, the institute, are SDEWES subjects. At least the 4 first issues are SDEWES subjects. So we are very happy to share the vision we have for islands with you, and all our activities carried out in our premises in Gran Canaria Islands. It's a very big installation, 110,000 square meters, close to the sea, so we can do with plenty of sun, plenty of wind, sea. We have also biotechnology installations, so microalgae biotechnology, another interesting subject when we speak about circular economy. And, well, you're invited to go there if you are in the Canary Islands. I don't know how many islanders are in the audience, but if you are there, so please contact me to visit us. So, I will talk about islands generally, but I will focus on the Canary Islands because we are committed in the public sector, and we are also convincing the private sector to focus on circular economy issues. And why do we have this vision? So, we are 7 islands plus 1 island with lots of people, but we have islands with almost 1 million people, like Gran Canaria or Tenerife, and we have islands with 1,000 people, 2,000 people, 10,000 people. So we have a variety of dimensions, and we have lots of tourism. This is actually a big pressure. I mean, it's good for our economy. We have developed a lot in the last 30 years, particularly because of tourism. But this means, since we do not have seasonal variations, this means a constant, an additional permanent population of approximately 300,000 people that sleep every night with us. And these 300,000 people consume 3 times as much water and energy. So it's an issue difficult to tackle. So, as it happens with almost every island in the world, isolated islands, so I will distinguish between islands which are connected to the mainland via a cable or a pipe, and isolated islands. We are isolated islands, so every island is a world itself. No? And as in most of the islands in the world, as I said before, the energy supply relies heavily on diesel. This is now and will be like that in the coming years if you do not take actions like the ones I will describe later on. So, in our case, we have a nice climate, but we have also a complex orography, so we can have heat demand in heights, let's say, above 600 meters above sea level. No? Almost all the population is concentrated on the coast, so when we speak about energy, we speak almost about electricity, but now we are thinking about heat also for these mountainous areas. No? So, lack of water. In islands, there are islands where it rains a lot, but in the Canary Islands it does not rain. So we were forced to use non-conventional water catchment methods like desalination, and actually 50 years ago we installed the first desalination plant in Europe in the Canary Islands. So we are leaders in technology in all these issues. And our obsession is to minimize the energy consumption of the water cycle. Not only desalination, but also pumping and distribution. No? So, as an insular region and as an isolated region, our goal is to be to maximize our endogenous energy resources, and in this sense, this binomial energy-water is critical for us, as I said before. So we are, for those of you who don't know us, we are close to Morocco. I mean, we belong to Spain, but we are close to Morocco. We are 130 kilometers away from Morocco, and this is what we are. So, additional challenges that islands face and that help to understand the vision I want to share with you. Most of the islands are rich in biodiversity, but also have fragile ecosystems. In the case of the Canary Islands, 4 out of 7 national parks are there. So almost every island is a biosphere reserve. Lots of land is protected. So in the Canary Islands, 50% of the land is protected, so you cannot place anything there. So climate change is affecting, I mean, not in our case also a little bit, but in the Pacific or in other more remote locations, climate change will affect drastically the population. And then we have the problem also of the population density and growth. No? There are other islands like Malta or ourselves in Gran Canaria where we have one of the highest population densities in the world. No? This is a problem, or this will be a problem. Waste is a problem. It's difficult for us in the small scale. Although small means beautiful, from the technical point of view, making things smaller is difficult. In energy issues, it's difficult. Now we see also the trend that in the water sector, everything is going to be smaller. On one hand, things are going to be bigger, big desalination plants in the Gulf and also in Australia. But on the other hand, we see also a trend to small things. And these small things are nice, but difficult from the technological point of view. So this is a problem, for instance, in biomass or in waste removal. It's difficult to find biomass technology below the 500 kilowatt range. So this is where we are active in, trying to find these niche technologies, these niche markets, make us strong, and trying to transfer all that we know and all we discover in this small world to the rest of the regions. So, food autarky. This is an issue. In the Canary Islands, we are a little bit behind that. We have lots of tourism, but we import almost 80% of what we consume. So this is really an issue on islands. sustainable tourism. We want to rely on tourism as first economic source of income, but it's difficult to make it sustainable for the reasons I spoke about. No? Transport. The weight of transport on islands is usually higher than on continental regions. No? But at the same time means opportunities, for instance, for electric mobility. Islands are the perfect places to foster and to develop electric mobility programs. We are also working in this direction. No? It's difficult to create new sectors with this, with sustainable new sectors, but we have also we see also potentials and opportunities in the blue economy. I will speak about them later on. And then, although we have plenty of sun, plenty of wind, it's difficult to deploy massively renewables. So our grids are weak, and it's a thing that we have to explain a lot. So it's not the same injecting renewable energy, variable renewable energy into a continental grid than in an island grid. So we have to perform dynamic grid stability studies with complex software just to foresee and to plan the renewable energy penetration. So, as a summary, in continental areas, the trend will change, but up to now, business as usual solutions. On islands, we are forced to apply smart solutions, circular economy solutions, and sustainable solutions. So, I will make now, so I will speak about energy and water mostly, but also about blue economy, climate change, and let me speak about a little bit of the Canary Islands in this sector. So, historically, as I said before, we have no water, there is no rainfall, so we have been forced to apply intelligence in order to guarantee a water supply. So we have done galleries, wells, dams, lots of things that now are useful for combining it with energy, as I will explain later on with our lighthouse project of Izquierdo. So we are one of the regions in Spain that uses water most efficiently, and this is a thing that our grandparents have taught us. So, I said before, 1964, we installed the first desalination plants, and almost 80% of the water we have on the islands comes from the sea. And we have about 600 desalination plants of all kinds, and also of all types of water to be treated. No? We have been leaders also in wastewater treatment and reuse. So now we are treating almost 60% of the water of the wastewater we produce, and the goal is to have 100% in the short term. Even in non-conventional solutions for wastewater treatment, we have done nice pilot projects. This is Gran Canaria. I don't know if you're familiar with this constructed wetlands, lagoons, that efficiently treat the wastewater without energy. I mean, we use gravity and we use the nature to treat the water. We have been very successful in places where we'll never be connected to a sewage network, or it will be too expensive, and then can treat up to water of 2,000 inhabitants equivalents. This is actually this system in Santa Lucia. It was intended for a small settlement. Now all the village is using like that. It looks like let's say like a resort, no? And it's a perfect example of circular economy. So we have created 2 jobs there. Apart from not using energy, you can collect the biomass, which is produced there for food for livestock, or even for doing a handicraft for tourists. So, desalination and energy. It's a problem for us, and we have been for 20 years, from the very beginning of our institute, we have been developing solutions for minimizing the reduction, minimizing the energy consumption of desalination, to optimize coupling of desalination and energy both through the grid as a critical load and in off-grid systems. As islanders, we have to specialize in off-grid systems, both water grids and also electricity grids. And so we have the two options: to optimize the cycle going through the grid and without going through the grid as standalone systems. So energy, we have, we are an industrialized region. So, we have 3 gigawatt installed power, and on the big islands we have 1 gigawatt, and in the smallest islands we have 20 megawatt, 15 megawatt. Again, this vision of references for other regions worldwide. So 15% of the electricity is consumed in the water cycle. I mean, having no energy, we can allow that, but having no water, it's a problem. So it's really an obsession to reduce this energy consumption in the water cycle. So now we will have in 2 years, if we are successful, now we begin to install 400 megawatt wind. We have now 10% renewable energy penetration. This is quite okay for an insular region. Huh? It may appear too low, but it's okay. But if we manage to do that, we will be a reference also worldwide in renewable energy penetration. This is not easy, as I said before. We lack of space. Our grids are not prepared, so we have to do lots of things to upgrade the grids, to plan it on the territory. So we have done lots of efforts to achieve this goal. So, and this is our vision. Our vision is that all these potentials, all these challenges we have to face, make us as a provider of solutions, not only for islands, but also for the regions in the developing and the less developed areas, like I will show you in West Africa, and also continental regions worldwide. So in the Canary Islands particularly, we have big islands where we can replicate, let's say, a big town in Europe, or we have these small islands like El Hierro, La Graciosa, from which I will talk a little bit more later on, where we can simulate isolated communities or rural areas of less developed countries. Sustainability, as I said before, 50% of our land is protected, so we are committed to that. We have all these awards, biosphere reserves, and so on. So it's a must to apply sustainable solutions in all these sectors. We are also focusing our R&D work, our cooperation work to less developed countries, and since we are very close to West Africa, lots of flights are available. We have been now working for 20 years also in transferring the technology to West Africa. So these are few examples of what we have done. In '98, in the frame of a European project, we managed to have the first off-grid wind farm ever, with two Enercon machines, two synchronous Enercon generators coupled to a flywheel, and to this isolated grid, stable in frequency and voltage, we connected different desalination plants to see which was the best combination. And from there, we have focused on renewables plus RO. So we have been doing with German researchers some R&D work in membrane distillation, which may compete in the medium term with RO in the small scale. But we have seen that the most efficient combination is renewables plus RO, either with using batteries or without batteries or going through the grid. So this is an example of a standalone system for rural areas with capacities up to 100,000 liters per day, 100 cubic meters per day, which is a patent and what we have installed in several sites in Africa. It's a system that can be packed into a container and can be transported. It's more or less plug-and-play technology. Plug and play for us, but if you go to Africa, it's not so easy. No? So the first promoters of renewable energies in the Canary Islands were water companies. So this gives you a hint of about the will and the cost. Well, I haven't spoken about the cost of electricity production on islands. If you use diesel, we have the most expensive systems in the world. We can have kilowatt-hour costs of 20 to 30 cents. Okay, so the same applies to Hawaii and to other islands worldwide, no? Or remote areas of less developed countries. And this is a nice example we have on Gran Canaria. It's an on-grid wind farm coupled to a desalination plant with special power electronics that is also using the water for agriculture. So it's also a perfect example of themes that we are discussing here at the SDEWES. No? So this is the work towards West Africa. We have working with Mauritania, Morocco, and even Tunisia for 20 years. And now we are focusing very strongly on West Africa. These are the less developed countries in the world. The electrification rates of ECOWAS countries. ECOWAS means Economic Commission of West African States. They have the lowest electrification rates in the world, the average below 20%. Lots of rural population, lack of infrastructure, so are the best places to implement this bottom-up approach. Not that, South Africa is another thing. It's a business model like an industrialized country, very big plans. Our focus is bottom-up, from small to the big systems, and this is the things we are doing there. So what we have done is we have been electrifying isolated communities with wind and solar energy using batteries normally and hybrid systems. So wind, solar, small diesel and battery. And we have also our added value is that we are also combining or introducing or including water in all our energy projects. These are examples of what we have done in Mauritania, very remote areas, in South Morocco or in Tunisia, where we have now, this system is now 10 years old, in Sargilen, so in the middle of the desert there, and it works perfectly. So the population has doubled in this small village, and they rely on this brackish water solar desalination plant. So also microgeneration. I will speak a little bit about distributed generation because we see there the solution to many problems in rural areas and on islands. And now we are helping, for instance, Cape Verde government to deploy the microgeneration policy in rural areas. It's a difficult thing. So a little bit about climate change. So some islands, and particularly the Canary Islands, are in boundary layers when we speak about climate change. So for us, it's important to know, to do a regional approach. And what we have done in the frame of a European project is to work with Moroccan partners to do a regional approach. I mean, to develop models at the mesoscale, and also to combine this with other more strange things like bird migration patterns. So we see there is a boundary layer, and we have detected very interesting things regarding I mean, not so very interesting, but not so positive for us regarding climate change affection to us. No? So this is what we have done using our supercomputers and defining the domains, configuring the WRF models, and we have done projections for 2090 to 2100, and well, they are not so nice, these projections. So we see even 6 degrees if we use the worst scenarios. No? And for instance, in an island like where I live in Gran Canaria, we have been also watching satellites observations from the late 50s up to now, and we see a deviation of the direction of the wind. This is probably affecting tourism in the medium term. So these kind of studies help us to understand a little bit more what could happen in the short and medium term and show these results to the politicians. No? So this is a very new project. We have been awarded together with the University of Barcelona and Palermo in Italy. And the European Commission seems to be very now keen on studying the nexus. So this project particularly studies the energy, water, and food nexus. We started right now. And these are some slides from the kickoff meeting 1 month ago. So you see, we will begin to study all this nexus, which is a main theme of this conference. Yeah, 20 Wageningen, Barcelona, and also Italy. So, blue growth, blue economy. I talked about microalgae, or algae generally. These are pictures from our installations there, where we're trying is to develop a new sector, the new agriculture. For us, it's a new agriculture. It's difficult to explain to the agriculturals that it's not like growing tomatoes. These small animals, these microorganisms are a little bit difficult to handle, but we think that this is a promising option, and we will concentrate on algae, environmental coastal protection, and also marine renewables. So this is some slides extracted from a presentation we made in a European conference held in the Canary Islands last year about RIS3. I don't know if you are familiar with that. In Europe, the Commission is asking the regions to specialize in things. And our smart specialization strategy is focusing particularly on circular economy issues. And so here are a couple of examples to show you what we have done or what we are doing. This is part of one microalgae production plant at our premises, where we are transferring all the know-how accumulated in 15, 20 years to the private sector. So we are hiring, we are renting our installations, and we let entrepreneurs come in. So we act as a kind of business incubator. And in other aspects, we are developing technology in regarding coastal water quality and protection of marine diversity, like this one. This is a diffuser for desalination plants, for brine of desalination plants. You know, when desalination plants produce the brine is poured into the sea. Sometimes it may happen that you have this concentrated brine flowing into one area, and it will damage, or it may damage, all the flora and fauna of this area. And with these systems, we have helped to renovate all the Poseidonia and Cimodocea donosa algae plantations, algae flora in some spots of the island. And also marine renewable energies. Islands are the perfect place, and particularly islands in the subtropical areas, for testing marine renewables. We are testing wave energy devices. I mean, in Scotland, it's okay, there is plenty of wind, plenty of waves, but there are storms. So if such a thing drops into the sea, you lose 20 million or 30 million. In the Canary Islands, there are not storms, so a perfect place to test. I mean, our potential is medium, but it's a perfect place. So we are testing right now 4 wave energy devices, and we tested recently the biggest offshore wind turbine constructed in Spain from Gamesa, in a record time, but because we have here 5,000 equivalent hours. So a capacity factor of higher than 50%. So this helps also boost technology in our regions. So, and finally, goal 100% renewable energies. This is what we want. It won't be easy. We are now, we now have the doubts of introducing a transition fuel like gas. There are lots of discussion about using natural gas or jumping directly into renewables plus storage. So there is a big political discussion right now, but our goal is to have 100% renewable energy supply. And we are starting from the smaller islands to the bigger islands. First, since water for us is a thing, so since water for us is a key issue, we have, when we use pumped storage, not only we provide a solution to the electricity sector, but also to the water sector. It's a thing that we have to explain a lot, and we will speak about El Hierro. I will have to highlight that because this is a thing that we have not monetized yet. Maybe Neven, it's a thing that we have to write an article about it because we don't have time, just to monetize the value of storing of this multiple water use. So, since we have dams, we are trying to use pump storage as an energy storage medium wherever possible, because it lasts long, and I mean it's a big capex, but it lasts long, and in combination with, for instance, desalination plants, we are seeing that it works, like we will see in El Hierro. Well, pump storage in combination with wind. Our wind pattern is very nice because we have the trade winds, and from April to September, the wind blows constantly, 3 months, 4 months. So we will have over capacity of wind energy in summer at night. So it's a perfect thing to combine with pump storage systems and to use the pump storage, but not as a generation plant, but as a regulation plant. So we are in conversations with the grid operator just to set up new business models for that. In fact, we are pioneering solutions for Spain. As we will see in El Hierro, a specific package of legislation was created because this wind pump storage system was not contemplated in any law. And these are things that, together with the technological innovation, need a little bit time. So, at the high voltage and medium voltage level, what we are doing to increase renewable energy penetration is to connect in some area, between some islands, to connect them electrically with subsea cables. We are also pioneers there because there are no technologies now in the market below 2,000 meters depth. So these are also new sectors where we are learning a lot. So, and this is where we particularly are very active in, microgrids, distributed generation, decentralized generation. So having a microgrid as a critical load, and we are working together with the utility. I mean, we have to work with the utility, and we are convincing the utility to enter these new sectors and yeah, letting these business as usual scenarios a little bit away and focusing on that sector, and we are managing to do this in La Graciosa as we will see. So we at our premises, we have a microgrid. These are our premises in Pozo Izquierdo, and we have lots of things there. We have even hydrogen. We have new batteries. We have a hydrogen car. We have PV, different desalination plants, so electric mobility also. We have some cars and some motorbikes. So there we are trying to define new things that we are extrapolating to the small islands. So then demand management. We are working also in having the desalination as a deferrable load, and this is done island by island, together with the grid operators and the water companies. And also electric mobility. We are doing at least studies. It's a market issue. I mean, the public sector, what can do the public sector is try to plan, to sit with the key stakeholders, and the market is evolving. We were discussing it last night. I think the market is evolving rapidly, and we will have soon thousands of cars in our islands. We have at the moment hundreds charging stations. I mean, for our circumstances, is quite a lot. And now 500 cars. So probably next SDEWES we will speak about thousands of cars. So also these technical issues regarding wind integration or solar or variable renewables integration into weak grids have to be discussed first in the academic or technological forums, because it's not so easy. You have to develop new grid codes, you have to develop new strategies, you have to study or you have to apply complex software to these systems to see where and how can we penetrate with big variable renewables into one particular transformer station. So we are learning it with software, but also hard, and we are applying this to several islands. This La Graciosa is Canary Islands. So en El Hierro, these are our two circular economy islands, and now we are expanding. Well, we have been working a lot together with Neven, with energy planning on islands, energy prospects for islands. And now we are strongly focusing on the electrical sector. And this is an FP7 project, a very successful project in the European Commission, where we had also utilities there. And now we have Tilos. Tilos is another a small island, small Greek islands, where we are about to install batteries as in La Graciosa, which I will show you right now. So this is all the experience we have accumulated. This is mainly a summary of what I have explained right now, and then the paradigm of our vision. So I will first talk about the ongoing project. It's not finalized, La Graciosa, and then I will finalize with El Hierro, which is our flagship lighthouse project. And I'm sure you will have lots of questions, so I will try to end in 10 minutes so that you can ask about that. So first, La Graciosa. La Graciosa has a nice feature. It's connected with Lanzarote here with a cable and a pipe. It's a small system. It's only less than 1 megawatt, so 0.7 megawatt peak, and has seasonal tourism. So this is a challenge for us. And there we are installing, together with the utility, which is the owner of the distribution network. We are doing it together, and we hope that we will have it in a couple of years from now, because some business models and some codes we are proposing are not yet in the legislation. So we will have to speak with the ministry to definitely implement the solutions we are proposing. And as an example, centralized battery or decentralized battery. This is an issue we have been discussing now for 3 years. So there, circular economy, we have waste, which is a big problem there. We have water. We are installing now wastewater treatment systems like the one I showed you before. We have the desalination plant coupled to the microgrid, and then finally this renewable energy microgrid, which may be isolated from the main island, Lanzarote. So some characteristics about the cable and the perfect object to illustrate one of the pillars of NEO. So the first smart meters in the Canary Islands were installed in La Graciosa, so we convinced the utility to do that. And these are the works we are doing. Well, the microgrid consists mainly of PV, distributed PV on the roofs. What we don't know exactly is how to, if you want to use one battery or several batteries, as I said before. And then electric cars. So now what we have managed is that the public sector, the cabildos we have, every island has its insular authority, and is investing now in PV and charging stations. There are 2 charging stations there, La Graciosa, where there are only few cars. So, but okay. So, and this is how it may look like in the near future. So, and this is our flagship project, El Hierro. El Hierro is an island with 10,000 inhabitants, with 7.2 megawatt peak, and with the former electricity supply based heavily on diesel. So, the population there and all the island 20 years ago developed a sustainable development plan, and then where they included, they wanted to be self-sufficient. So before it was declared biosphere reserve, the Cabildo went to the government and to the utility. So I can remember that date, it was 99. Sit down on a table. We want to be self-sufficient. So let's start to work on the technical part and on the capex part, because the wind pumped hydro system I will speak about later on is a heavy investment. Okay. So, and this is all the richness of El Hierro, biodiversity, and these are the fields of the sustainable development program. So it connects all the sectors. No? So the first, one of the pillars of this 100% renewable energy supply strategy is this pumped hydro power station. So we have seen that it was an idea that was proposed 30 years ago, but 15 years ago we began to work hard on it. And as I said before, maybe now it's not the best solution from the electrical point of view, because there are new and cheaper options, but the water aspect is critical. So the agriculture is happy on the island because they have now the upper reservoir as a regulating reservoir. And this is what we have to monetize, because there are a lot of criticism about if it's too much expenditure and so on, and we have to explain that more. No? So, which model did we use? So first we signed an agreement. The government of the Canary Islands told us to be the technological dynamizer or catalyst, and then the utility and the insular corporation. So first we signed an agreement, and when we looked for the money, we converted this agreement into a company. So first think how to manage the company, how to manage the shares of the company. These are more social things, but are discussed also in this forum of SDEWES. So we decided 60%, the bigger part of the shares to the Insular Corporation, and the rest to the technological institution and to the utility. And the ministry in Spain, the Ministry of Energy, gave us a grant of, that time it was 50% of the investment. Now it's a little bit less because the investment went up to 82 million euro. So if you calculate, then it may appear too high LCOE, but it's not that high, okay? So, and then this was in 2006, so 7 years after the idea was born, and the system looks like that. So it's a wind farm, and I mean the distribution the distribution network is a 15 kilovolt system. We haven't done anything there, but we have only installed generation units, electricity generation units, and specific power electronics to regulate and to stabilize the grid. Okay, so it's actually a replacement of conventional generators by renewable energies and I mean wind and hydro, and with the aim of having the existing station as a backup. Okay, so there are 2 generation systems on the island: the wind hydro system and the diesel. And the diesel, when we designed it to have 100% for the periods of the year where the trade winds are blowing. Okay, some people are claiming, well, it's not 100%, it's 100%. The technico-economical optimum of the design is 100% between April and September. So it can be 100% from April to September. And the rest will be done with biomass, PV, management also with electric vehicles. We have lots of electric vehicles already on El Hierro with 6 charging stations. So we are pushing there to have the system running as soon as possible. I mean, running 100% concept, but the wind hydro station is running now, has been running now for 2 years. And we are improving it from day to day. So a wind farm with wind Enercon E70 machines. These are synchronous machines, which are the best technologies to supply to, let's say, isolated or weak grids. And then we have 2 reservoirs where we have used a natural crater, and here it's an artificial reservoir which has become a little bit too small. So we couldn't foresee that. It's a little bit too small. So because this is the reservoir that determines the autonomy of the system. Why not to use the sea? Because of environmental things. So to do to carry out a project like that, the permissions and so on would have taken a lot. So we decided to use, but it can be done with seawater without problems. I mean, from the technological point of view, it's not a problem. So, and the operation is, yeah, you know that. So we when the demand, or when the wind blows, and either the demand is covered, or the grid operator says you are not allowed to inject more into the grid because there is a grid operator there, okay? Then we use, and when the wind continues blowing, we use this excess wind energy to pump water from the lower reservoir. It's desalinated water. So the desalination is also a load, an internal load of the system. We use it to pump water, and when the wind stops blowing, immediately, so in milliseconds, we have the hydro running. We have actually one turbine always running, just to guarantee all the measures that are requested from the grid operator. So it's like that. It sounds simple, but it's a complex piece of engineering there. And my intention now is to have to show you now how the system was constructed, all the evolution. These are once again the main figures. So here, these are 4 Pelton turbines of 2.8 megawatt. I will show you them later on. And here we have a combination of 2 big pumps of 500 kilowatt and 6 times 1.5, 4 times 1.5 plus 2 500. I will show you right now. And the upper reservoir, which also works as a regulating reservoir, and the lower reservoir, which is a little bit too small, but we cannot do anything. Maybe connecting. We are thinking about connecting with another one, with a new one, but we are not sure what to do there. So these are not pictures, but drawings done 15 years ago. Okay, this is a drawing, and this is the upper reservoir. So it's a natural crater where that we emptied and waterproofed. This was never done before. Once again, this reference or testbed. So we asked all over the world, and no one had never emptied and waterproofed a crater. So we learned a lot, and it was actually a lot of money invested there. So if you see, this is a track, okay? So that you see the dimensions. It's like 25 football fields. You see the cranes. This is the newest technology. Maybe you're familiar with that. It's geotextile membranes. Difficult it was difficult mainly because of the volcanic origin of the Canary Islands. So we had a couple of problems there. You see here how it is installed. No? Well, and this was fun. We began with the works in 2009, and we ended in 2013, 14. So 4 years. So we have 2 conductions. We could have used 1, but we used 2 conductions. And this is also a big piece of engineering here. The lower reservoir. We receive lots of visits from all over the world. The hydro station. These are the turbines. Well, the turbines have, as a regulating system, a flywheel coupled to the turbines, which provides an inertia of 6 seconds, which helps stabilize all the network. And then the pumping station. This is 1, 2, 3, 4, 5, 6. So there are 4 small pumps and 2 big pumps. And the wind farm, which was also difficult to construct there, no? Day and night. We had even to change a little bit streets on the island just to allow to install the system. So we inaugurated here, 1 year in testing mode and 1 year now in commercial operation. So according to the law, which was specifically designed for the system. Now it's coming. We are coming with electric vehicles. This is now appearing in every papers and magazines worldwide. Charging stations. Lots of publicity. And thank you very much.
So thank you.
5 minutes more.
So we have time now for some questions. Please, Nevan.
Thank you very much for demonstrating excellently how we have to integrate everything in order to reach sustainable development. But I have a very technical question. Can you use reverse osmosis pumps also to take part into the flexibility of the system, or they have to run full time in El Hierro?
This is a very good question. It's a very good question, Evan. So it could be done. The desalination plant is now a load. It's a constant load of the system. But I'm sure the engineers are thinking about it using as a modulating load. But I don't know now exactly which is the power of the desalination, because there are 3 desalination plants on El Hierro, and one specifically connected to the plant. I think it starts and stops several times a week. It's a constant load, but on-off. So it's a good question. I have to ask the engineers of Corona del Viento. Now this is a company running independently of us. So we are sometimes consultant to the company, but I will ask, and I will come back to you, Neven, because it's a good question, and I'm sorry that I cannot answer you.
Peter Varbanov from the Pazman Peter University in Budapest. You mentioned waste, and you mentioned high population density. So a key issue is what happens with the waste.
Mm-hmm.
And in this relation, is there any waste to energy effort?
Well, yeah, there is a waste to energy effort in the biggest landfills. Okay, so we have a city of Las Palmas, the city where I live. It has 400,000 people. So it's a big city on a tiny island, a very big city. There we have a landfill, and we have a 3 megawatt biomethane plant. Tenerife has also a similar one, and Lanzarote, which is the next island in population, has a 1.5 megawatt plant. So we are beginning to do this small scale, because 3 megawatt, Peter, is small scale. No? Well, yeah, but with the legislation in Spain right now, it's not economically, it's not really a business. So you have to do that, yeah. But the scale is small. No?
Yes,
Andrej Vojáček, Czech Technical University. I have 2 simple questions. First is, what is the model of financing this project? Is it private finances or public, or is there any combination? And the second question, you mentioned some project in Africa with renewable resources, etc. We discussed it on the platform of Czech Austria Energy Group, and we saw many projects that was invested in Africa, but afterwards, when the financing stopped, the sustainability issue occurred, and how you cope with it?
Very good question. So first question regarding financing. In the El Hierro, without this public grant of 35 million euro, the project wouldn't have been done. Okay, so this has to be done. This has to come from the public sector. At least this first of its kind. Okay, it was this 82 million may appear too high, but we had, because of the orography and all the things, that we found a natural heritage. So if we have done the project right now, it would have cost 50 million. Okay, on a, let's say, reference scenario. But we got the grant, and what we have done with the ministry in this legislation is to have the installation paid back in 20 years. Okay, there is in Spain a specific legislation. You have to have an IRR in the energy business of 7.5%. So this is the issue, and we discussed it with the ministry to have this private part being paid back in 20 years. In Africa, well, in La Graciosa, small PV, it will pay itself. This is why Endesa is now with us, because they see we may achieve their generation costs below 15 euro cents per kilowatt hour with the battery. Okay, total LCOE or generation cost below 15 euro cents per kilowatt hour. And regarding Africa, we take care a lot about the continuation of the project. So in all our projects, we try to have financing also for 1 year post-installation operation. We take care about training the technicians. They come to our premises. We go there, and they are trained. And we try to guarantee with the fund, because it's also public fund. This is cooperation money, still cooperation money, but soon it will change. Okay, we try to guarantee at least 1 year operation after the system is commissioned. So this is why our project, at least the majority of them, are still working after they have been installed. And then the next point is coming now in Cape Verde, in ECOWAS, where we are telling the politicians there to develop business models for off-grid systems. This is also a very complicated thing. Business models for off-grid systems in places where people do not have money. So micro-credits and all this stuff. No?
Yes, please.
Michael Walmsley, University of Waikato, New Zealand. With all your tourists, 300,000 per night, is there opportunities for biogas production from the waste of all the tourists?
Mm-hmm. Well, not only the tourists. We are trying to, we have mapped all the biomass resources by municipality, by hotel, no? And it begins to make sense economically to install small biodigesters. I'm talking about small biodigesters that 2 years ago were too expensive. But right now, they are beginning to provide IRRs of 6–7%. So soon we will see that. And once again, this testbed reference circular economy models, it's not so easy to find places where you see small biodigesters, except for Colombia or China, where they have to be implemented in rural areas because it makes sense in very low technology. Here, we have to apply the little bit high tech in these small scale things.
Yeah, a quick one. What is the price of electricity and water compared with mainland Spain?
Well, in Europe, all the countries have the same electricity price everywhere. So in Spain, the price is the same in Madrid than in Las Palmas. But this will change. Huh? And this is what we are claiming to the government and to Europe. Let us have our specific energy retribution scheme.
Yeah.
And this is another thing to do with you academic guys to develop things. It's not so easy to have this, let's say, regional economic markets, renewable energy markets. Huh? Now we are happy on one hand because we are not paying 3 times as much, but we are unhappy because we cannot develop renewables.
One thing you should say to Yoshi is that the cost of diesel for producing electricity is 3 times higher
Exactly.
than the price.
In El Hierro is 3.5. El Hierro is one of the most expensive systems in the world, insular systems. Like Hawaii, it's 32. With a barrel at $100, it's 30 euro cents per kilowatt hour, like in Hawaii.
Let's go for the last question.
My name is Mohammed Shiab. I'm from Qatar Foundation Research and Development. Thank you for the very interesting presentation. Actually, in your project, you tackle the most grand challenges in most vital sectors, energy and water. I saw that you have very promising and very good achievement in integrating all sorts of power generation. You mentioned the hydropower, you mentioned the wind energy, and you mentioned the solar energy. But did you consider in Canary Islands desalination powered by solar energy, or I didn't see the solar energy in the whole system?
I'm a solar energy man, so solar energy is the energy of the future. I mean, PV will be the cheapest energy, and everyone will have PV. What we have done is to develop let's say, containerized solution for desalination with PV at the low scale, but for off-grid systems, okay? If you apply it on a large scale, first you need lots of space, so wind is cheaper. Wind is now cheaper than sun in the Canary Islands, because we have, wind we have now 5.5 cents per kilowatt hour is our production cost in windy places. So, but soon we will see the break even or this parity. And what we write in our papers is, in the medium term, we will see in the hotels standalone desalination plants powered with PV. But in our cases where we are industrialized and there is lots of consumption, you need very big things. So what we are doing is trying to have this desalination as a critical load in an insular system, going through the grid and speaking with the grid operator to do demand-side management. And off-grid systems, it's too early for our industrialized regions, but it's now good for Africa, where, for instance, in Mauritania, you pay in Bagdargan for the alternatives to bring water to a remote area, because this is a big problem of West Africa. You see the women and the children with these tanks. They are looking for water. So when there is no water in a place, there are two options: go into the cities, this rural exodus, or delivering the water with tanks. So we are familiar with all the costs, and in Mauritania, for instance, it's 15 euro per cubic meter, what it costs, bringing the water with the tank there. But if you use PV or wind, depending on the availability of the resource locally, we have managed to go down below 3 euro per cubic meter, which is for us, Canarios, too high, but for them, in comparison with 15, very cheap.
So what is the level, the potential of wind, the level of wind in Canary Islands?
The level?
Of wind, the wind potential, why it is more
we measure it with equivalent hours, like the sun. It's the easiest things to do. I mean, we are not an academic institution. You will kill me. I'm particularly an expert on that issue. But we have in our windiest places have 5,000 equivalent hours, so capacity factors above 50%. And solar, we have also near 2,000 equivalent hours. So the potentials are enormous. You have to come to the Canary Islands to test that.
Thank you.
Okay, so let's thank again our speaker. I have a certificate to give you.
Thank you, Mario.
So, nice. Now it's time for lunch. We should be back here at 1:30.
Yes.